All right, so this unit is pretty long. There's a lot of different lessons involved, but before we can really get into anything, we kind of have to review some pretty old concepts that you learned quite a while ago, but may have not remembered because we haven't used them for a little while. So let's get into the idea of polynomials again, right? So what is a polynomial? There we go. Polynomial. So a polynomial is an algebraic expression, meaning letters and coefficients. Algebraic expression containing many terms. All right. The terms consist of numbers called coefficients. So these are just the numbers, the actual values we see. Coefficients and letters called variables. So a given term in an expression might be something like 4x squared. This would be the coefficient, and here would be the variable over here. Another one might be something like 2a. 2 would be the coefficient, a would be the variable. So the exponents on the variables for a polynomial, they have to be whole numbers. Now, they could be positive, they could be negative, but they do have to be whole numbers. And a number with no variable is called a constant. So, for example, if I had an expression 4x squared plus 3, the 3 would be a constant. It has no variable attached to it. Now, polynomials can grow in size, but we're going to focus on the simplest to start with. So, for example, if you have a polynomial with only a single term, so maybe it's just 2a, this is what we call a monomial. And it gets its name from the term mono. Mono means one. Now, maybe we have two terms, something like 4x squared plus 3. In this case, this is what we call a binomial. Bi means two, like binary, that kind of thing. A polynomial with three terms, maybe it's something like, I don't know, let's say 8x squared plus 2y plus 3. Right? This is what we call a trinomial. Anybody with a tricycle knows that tri means 3. So great. Now, there is a little bit more terminology that we have to think of. There's this term called a degree. Now, we've obviously heard that word many times, but the context that we hear it actually matters. For a polynomial, the degree of the polynomial is the largest exponent of any of the terms. So, for example, in this trinomial here, this polynomial, the x squared is the largest exponent. So our degree here is a degree of 2. Okay, so let's do an example. For the polynomial negative 2x to the power of 6 plus 7x minus 3, which is what type of polynomial is it? Well, we see 1, 2, 3 terms. So this is going to be a trinomial. And what is the degree? The degree is 6. This is the power on the largest term. The degree is 6. And the only constant we have here is the minus 3. If you have more than one constant, then you combine them and you get a final single constant. So in this case, our constant is minus 3. Okay, so this is the basics. Let's keep going though. An algebraic expression can be simplified. How do we simplify these things? Well, we collect all of our like terms. For example, if I had a 2x plus a 4x, I would combine those into a single 6x. So we combine our like terms. Like terms are terms that contain the same variables. Now this is important though. They have to be the same variables raised to the same exponent. So for example, if I have 2x squared plus 3x plus 2x, these would be like terms. I could combine them because they both have variables to the same exponent. This one is going to be all on its own. It's got a different degree, so I can't touch it. So algebraic expressions can be simplified by adding or subtracting the coefficients of the like terms. So this one over here would become 2x squared plus 5x. So I add or subtract the coefficients, the numbers in front. Okay? So this is going to allow us to simplify our equations. or expressions, I should say. Let's keep going. We got a little bit more. We're not quite done there. Let's do a little example here. So let's say we have example 2 down here, which is 5x minus 3y minus 4x plus 10y minus 2. So our goal is to combine the like terms. So look for the terms with the same variable. In this case, I have 5x and I have minus 4x. I can combine those. So 5 minus 4, that's just going to give me x. Now over here I have negative 3y and 10y. So I have negative 3 plus 10, that gives me plus 7y. And the minus 2 is all on its own. So we just say this term simplifies to x plus 7y minus 2. Great. Let's try the next one. Pause the video if you can and try and do it on your own. The next one's a little bit more tricky. So now that I'm looking at this, I have to really understand what the terms mean and how they're related. So let's try and find anything that's similar. So this first one, 6x squared y. Is there anything else with an x squared y? It doesn't look like it, but there actually is. This one and this one that has the same variables, x squared and y. They just don't happen to be in the same order, but that doesn't matter. Why doesn't it matter? Because if I have a times b, that's the same thing as saying b times a. And that's what we have here. We have x squared times y, or we have y times x squared. It's the exact same thing. They're just interchanged. So 6x squared y minus 8yx squared, that's going to give me negative 2x squared y. Now you're probably wondering, why did you write the x squared first? Because it has a higher degree, so that's what I'm going to work with. It's always better to have your highest degree, highest orders on the left-hand side and work your way to the right. Do we have any other similar ones? Is there any just xy? No, there isn't. There's an xy squared, but not quite. So we're just going to say minus 2xy. That one's all on its own. Xy squared, is there any of those? Nope, there's not. So we're just going to, it's added, so we're going to add it on there. Xy squared. You're like, hey, shouldn't we be flipping those signs? We can. So that is, why is my eraser not working? We absolutely can. I could write this as y squared x. Sure, doesn't hurt anything to do that. And then finally we have minus 5y. Okay, are we all done? Yeah, we can't really simplify that one any further. It's about as good as it's going to get. So now what? Well, I'm actually going to keep going with this because when we look at this term here, remember what I said, we want to sort these things so the highest order degree is on the left-hand side. This one's got a square. Neither of these two do. So I'm going to reorganize this a little bit further. So I'm going to say minus 2x squared y plus y squared x minus 2xy minus 5y. There we go. So now we've simplified it as much as we possibly can and made sure that it's as readable as possible. So let's keep going. Not done yet. So this one, we're going to remind you of something you haven't done in probably a little while, but we want to use the distributive property if we have some value on the outside of a set of brackets. So when we do this, we want to distribute that outside term through each term inside the brackets. So it would be a times b and then a times c. Now, if there were more terms, I could keep going. A times d, a times e, and so on and so forth. So this becomes a times b, well, that's just ab, plus a times c. So that's just ac. So we just multiply all the terms inside the brackets by whatever's in front of the bracket. Now, in this case, they're just general variables, but it's not always as simple as that. So let's try a couple here. This is going to be an instruction you're going to see a lot going for. Expand and simplify. It means get all the values you have and then simplify it as much as you possibly can. So here we have 6x squared minus xy plus 4. I don't really have anything on the outside there, so I can just drop the brackets. So this is just going to be 6x squared minus xy plus 4. Over here, I have minus 7x squared plus 4xy minus 2. Can I just drop the brackets? I can't. Because really this minus sign, that actually matters. That's the same thing as saying minus 1 right here. So that means we have to multiply that minus 1 through the entire set of brackets. So that means minus 1 times 7x squared. That's minus 7x squared. Minus 1 times 4xy. That's going to be minus 4xy. Minus 1 times negative 2. That's going to give us positive 2. Okay, so we have all of our terms. So we've expanded. Now we need to simplify. So we're going to collect all of our like terms. I have an x squared here, 6x squared, and the only other one I have here is the minus 7x squared. So 6x squared minus 7x squared is just minus x squared. Here I have a minus xy. Do I have any other xy's? Ah, right here. Minus xy, so that's the same thing as minus 1xy, minus 4xy. So that's going to give us minus 5xy. Okay, now we have y and a plus 2. Those are not related, so we can't really combine them, so we just have our y, and then we have our plus 2. So we've expanded, and now we've simplified, so both steps are done. Over here, we can do the exact same thing. We got to do the work. Well, we can distribute at this point, so I can multiply that 3 through this set of brackets, and I can multiply this negative 5 through this set of brackets. That minus sign goes with the 5. So we're going to have 3 times 4a, and then we're going to have 3 times minus 7b. Over here, we're going to have minus 5 times 2b, and minus 5 times minus a. So let's do the work. 3 times 4a, that's 12a. 3 times minus 7b, that's minus 21b. All right, now we have minus 5 times 2b, that's minus 10b. And then we have minus 5 times minus a, that gives us positive 5a. So we collect our like terms and simplify here. So do I have any just a's? I got 12a and plus 5a, so that gives me 17a. Now we have negative 21b minus 10b, so that's negative 31b. And that's it. That's as simple as that one's going to get. Okay, so it's time to remind you of all of your exponent laws. We haven't touched on this at all in the grade 10 course yet, so you'll have to kind of remember from your previous years, but hopefully you've got everything in your back pocket and it's right at your fingertips. Okay, so when we have a set of powers, so when we're multiplying powers with the same base, what we're going to do is we're going to keep the base the same, and we're going to add the exponents. So over here we have a to the power of m times a to the power of n. So they both have the same base. So all we have to do is add the exponents. So here we have 5 to the power of 4 times 5 to the power of 2. So we keep the base and we add the exponents. So it's going to be 5 to the power of 6. So that's our addition. Let's call this rule number 1. Okay. Now we have division. Division is the opposite. So if we are dividing powers with the same base, then we're going to keep the same base and we're going to subtract the exponents. So multiplying we add, and dividing we subtract. So a to the power of m divided by a to the power of n is just a to the power of m minus n. So here we have 4 to the power of 5, so we're going to keep the same base. And now we have 5 minus negative 3. So that becomes 4 to the power of 8. Great. So now we're going to start to get a little bit more tricky. What if you have a power of a power? So when you're taking the power of a power, we're going to keep the base again. We're going to keep the base the same. This time we're going to multiply the exponents. So I have a to the power of m to the power of n. So we're just going to multiply these two together. So a to the power of mn. So here we have 3 to the power of 4 to the power of 4. So we're going to multiply those two exponents. So 4 times 4, that's 16. So we have 3 to the power of 16. Big number. Negative exponents. So if you have some base to the power of a negative exponent, what we're going to do is we're going to take the reciprocal of a, reciprocal of our value, of our base, the reciprocal of our base, and make the exponent positive. So here we have a to the power of negative n. That's equivalent to 1 over a, because a is a over 1, really. So the reciprocal of that is 1 over a to the power of n. Here we have a half to the power of negative 3. So I'm going to take the reciprocal, so that's the same as 2 over 1, to the power of our positive exponent, 3. I can rewrite this because I don't need the over 1 stuff, so I could just write 2 to the power of 3. There we go. All right, the last one. Zero exponent. Sorry, I forgot to write our rules out. This is rule 2, this is rule 3, rule 4, and finally rule 5. Our zero exponent. Anything to the power of 0 is always equal to 1. Anything to the power of 0 is always equal to a 1. So a to the power of 0 is equal to 1. 35 to the power of 4 to the power of 0, that just means this whole thing is to the power of 0. Anything to the power of 0 is just 1. So that's your answer there. All right, let's put this to the test. Let's see how well we learned. Try and keep all of our rules visible here so while we do this. So what I'm going to do is I'm going to solve these, and I'm going to write down the rules that we're applying each time. So in this first situation, we have a whole bunch of powers and similar bases. So here we have a squared times b, and the coefficient is negative 4. On the right-hand side, we have 3ab to the power of 4. So what we're going to do is we're going to multiply the powers, which means we have to add the exponents, okay, for each one of these separately. So negative 4 times 3, that's just negative 12. Now we do a squared times a. They have the same base, so we add the exponents. So that's going to be a to the power of 3. And then we have b and b to the power of 4, so we add the exponents. That's going to be b to the power of 5. There we go. Now let's see if we can do the same thing over here. No, we can't follow that. So this was rule 1, the multiply rule. This is definitely not the rule 1. In this case, we have a power of a power. So this is going to be rule 3. Power of a power. And what that one says is we have to multiply the exponents. So we have 4, and then m, and we have to multiply the exponents. 3 times 3, well, that's 9. Okay, hard to read that. Let me just erase it and write it again. Come on. Software. Try one more time here. So 4 with m to the power of 9, we multiply the exponents, and then we have n, 4 times 3, that's 12. So 4, m to the power of 9, n to the power of 12. So that was rule 3. Over here, what do we got going on here? Well, we got a whole bunch of fractions, but more importantly, we have an exponent, a negative exponent. And the rule says when we have a negative exponent, this is going to be rule 4, negative exponent, we're going to flip it. So we're going to take the reciprocal and make the exponent positive. So this is going to be the equivalent of x squared over 3, and that whole thing is squared. And we still have our plus 5x to the 4th over 6. Well, what can we do here? Well, we still have a regular old exponent out here. So we got to take that exponent through each term inside. So that means at the top, what rule are we applying here? In this case, we have our rule number 3. So we're also applying rule number 3 in this situation. So we have a power of a power. So in this case, we have x, and then we multiply the two powers. So we have 2 times 2, that's 4. On the bottom, we have 3 to the power of 1, really. What's 1 times 2? Well, it's 2. So 3 to the power of 2, that's 9. Okay? And now on the other hand, on the other side, we still have 5x to the power of 4 over 6. Nothing has changed. But now we gotta solve fractions the way we've always solved fractions. We need a common denominator. What's a common denominator we can get for 9 and 6? Closest one is going to be 18. So what do I have to do to each one of these fractions to get a denominator of 18? So the first one, I have to multiply both the top and the bottom by 2. So I end up with 2x to the 4th over 18. And we're going to add on to that. What do I got to do to the 6? I got to multiply it by 3. So that means I'm going to have 15x to the 4th over 18. So now we can keep going. We need to combine everything, and we end up with 2 plus 15, that's 17x to the power of 4 over 18. That's our final answer, no matter how beautiful it is. Okay, let's go over here. Now, the first thing you should see that should jump out at you is a power of 0 here. So that means that we're going to be applying rule number 5. Okay, and just to the right of that, we see a power of a power. What's a power of power? That's rule number 3. So we're applying 2 rules in this case. So I'm not going to multiply that negative 3 through because I want to deal with this power of 0. So that's really going to be negative 3, and anything to the power of 0 is 1. Well, that simplifies things quite a bit. And then to the right here, we have this 2x y to the 5th to the power of 3. So that means that we need to multiply, because we have a power of powers, we're going to multiply the exponent to each of the exponents inside. So we have 2 to the power of 3, that's 8. 2 to the power of 3 is 8. You know what? I will write that whole thing there so you guys can see it. So this is 2 to the power of 3, and then we have x to the power of 3, and we have y to the power of 15. Remember, we're multiplying the exponents here. Okay? And we can simplify this. Negative 3 times 1, that's just going to give us negative 3. We'll leave that alone for a second. 2 to the power of 3, that's 8. And then we have x to the power of 3 and y to the power of 15. Now we can multiply our negative 3 through, and we end up with negative 24 x to the power of 3. Let me undo that a couple times. There we go. X to the power of 3 and y to the power of 15. Now this is all one term. That's why when we multiplied it through, the negative 3 only applied to the coefficient of 8 there, because this whole thing is one term. There's no pluses or minuses or anything like that. It's just one term. Okay, let's go on to the next one. And this one, we're going to actually have to apply a few rules. There's the obvious one. We have a negative exponent, so we know that we're going to be applying rule number 4 first. So we're going to flip the fraction. So we get our reciprocal. So on the top, we're going to have 3x to the power of 9, y to the power of 7. And on the bottom, we're going to have x cubed, y squared. And that whole thing is to the power of 3. So that's rule number 4. But now we have a power of powers. So that means we need to apply rule number 3. So we are, for every term inside, every part of each term, we have to factor that 3, that exponent of 3 on each term. So that means 3 to the power of 3, that's 27. X to the power of 9, 9 times 3, that's also 27. So that's going to be x to the power of 27. And then we have y to the power of 7. 7 times 3, that's 21. And then below we have x to the power of 3 times 3. That's going to be x to the power of 9. And y, 2 times 3, that's 6. So this, we had to use rule number 3. Are we done yet? Not quite. We still have a division going on. So this fraction is really just division. So how do we deal with division? We subtract our exponents. So we're still going to have our 27, but now it's going to be x 27 minus 9. So that's going to be x to the power of 18. And then we have y of 21 minus 6, so that's y to the power of 15. So this was division, rule number 2. So we had to apply all 3 rules here. Okay. Now, ideally speaking, the more you do this, and this is one of those units where you just need a ton of practice to start to be able to see what you need to do and when, which rule you need to apply. So don't just assume because you know the rules, you can just jump in and solve the problems. Take your time, Try and remember all the rules before you dig too deep. Okay, so let's go again because we have a lot of rules to apply again. So in this case, what are we going to do first? Well, we have to deal with the fact that we have powers of powers. And on this one on the right-hand side, we also have a negative reciprocal, a negative exponent. So let's do our power of powers on the left here first. So that 2 needs to be multiplied by each exponent inside. So that's going to be a to the power of 8 and b to the power of 6 over a to the power of 10 times b to the power of 12. Now that's still going to be dividing something on the right-hand side. Well, we got to get rid of this 1. So that means we got to flip the fraction here because this is a negative 1. So we got to take the reciprocal. So that means on the top we're going to have a squared 9. And on the bottom we have a to the power of 8. And then b power of 5. So what rules did we apply here? Well, we applied the power of powers. Great. And what else did we apply? We also applied the negative exponents, so we applied rule 4 as well on this one step. Now, you might be like, wait, Mr. Lane, you forgot something. You forgot the fact that this whole thing should be to the power of 1. Well, anything to the power of 1 is just itself, so I didn't really need to do that. So we'll write it in there so you can see it, but it doesn't change anything. So we're just going to move on to the next step. So we finished that one, but now what you can see here is we're actually dividing. We're dividing fractions, which means we got to multiply by the reciprocal. So I have a fraction here divided by another fraction over here. And how do we deal with this? If I have a over b divided by, let's say, c over d, that's the same thing as saying a over b multiplied by d over c. So we always multiply by the reciprocal, if you recall. So we're going to leave the one on the left. So we have a 8, b 6 over top of a to the power of 10 and b to the power of 12. And that's going to be multiplied by the reciprocal. We can get rid of the exponent of 1 because it doesn't do anything anymore. So we have a to the power of 8 and b to the power of 5 over a to the power of 2 and b to the power of 5. So what did we do here? What rule did we apply? We didn't really apply any of our rules up here or any of our exponent laws. We just applied basic fraction rules. So we're dividing fractions, which means we multiply by the reciprocal. Okay, are we done? No. What we have to look at now is we have division in each term here. So each term has its own division. So what do we do with division? We subtract the exponents. So that means I have a to the power of 8. So 8 minus 10. So that's going to be a to the negative 2. And then we have b, which is 6 minus 12. That's going to give me b to the negative 6. And over here on the right-hand side, we have the same idea. We can put this in. I guess we can continue writing it with the multiplication sign. If you're not comfortable with that, you're worried that you're going to get things confused, you could always try two things. You could always use the dot multiplier sign. I don't know why my undo's not working there. What is going on here? Oh, there we go. It's working now. All right. So I could use the dot sign, and that also means multiplication. So that's fine. Alternatively, we could actually just draw in brackets. We could say, well, there's this term, and then we have another term over here, which is going to be a to the power of 8. So 8 minus 2 is going to be a 6. And then b, which is 5 minus 5. What does that mean? It means that I think I made a mistake somewhere. No, that's right. Oh, this is not a 5. This should be a 9. That's what I got confused by. Let's see. I think it's just my handwriting that kind of got everything confused here. We flipped the fraction so that a2, and this should be b to the 9. And then we have a8 and b5. I think that's why I got confused. I apologize for that. Yeah. and then we multiplied by the reciprocal, so it got flipped again. So we have a to the 8 and b to the 5, and then a to the 2, and this should be b to the 9 here. That's why I was getting confused. Right, so now when we do 5 minus 9, we get b to the negative 4. That makes more sense. Okay, so now we're multiplying. What do you do when you multiply? You add exponents. So you would think we're done, but not quite. So let's look at it. So we add the exponents. We have a, negative 2 plus 6, that's a to the 4. And then we have b, negative 6 plus negative 4, that's b to the negative 10. Okay, what rules are we applying here? Well, in this case, for this step here, we had division. So that's rule number 2. In this step down here, we had multiplication. So that's rule number 1. But are we done yet? No, because we can simplify this a little bit further. We have b to the negative 10. B to the negative 10. Well, that's our negative exponent rule. So we can rewrite this as the reciprocal, which is 1 over b to the 10. So if you then factor that 10 through both terms, that means we have 1 to the power of 10 over b to the power of 10. Well, that's just 1 to the power of 10 is just 1. So that's just 1 over b to the power of 10. So we can rewrite that as this term right here would be a to the 4 multiplied by 1 over b to the 10. So if we multiply that a to the 4, what we end up with is just a to the 4 over b to the 10. There we go. A over 4 over b over 10, or b to the power of 10. What rule did we apply that time? We applied the negative exponent rule. We just had to understand where all that work was coming from. Okay? Okay. I think that's probably good. If you keep going down in this stuff a little further, after you do your homework, you're going to come into this big old table, which is kind of like a flow chart on how to go through and solve factoring problems. This one is not great. I'm going to supply a better one in class. It's a little bit more simple and easier to follow. So I would just ignore this for now. And if you want to try and fill it out, you're welcome to. But I'm going to give you a better one in class, as I said. All right. Next lesson, we're going to get into the actual unit. That was all review so far. Let's see how it goes.